All right, back to this. So we have some lines of best fit that we have drawn on here, right? Now, every one of these graphs has a blue dot, has blue dots, right?
Yeah.
And 2 graphs have a black line, 1 graph has a green line. Now, which colored things on here are actual data points?
The top.
Which colored objects on here are actual data points? The blue ones, right? Where did I get the blue ones from?
The graph or
the table. Okay. Now this was just I just picked points that would help me prove my point. All right. So this is not actually measured data. But we could say this is the number of pieces of candy eaten per hour. So first hour they ate 1 piece, second hour they ate 2 pieces, third hour they ate 5. Right? Does that make sense? So this could be data, but it's not really. It's just points that I picked. Okay. But these were the points I was given, right? So that means that this right here is my actual y. And this right here is the actual y. And this one down here is the actual y, because those are the ones that we were given, right? That's the data point we were given. Those are the actual y. Okay. Does that make sense? Now, usually we'll use an equation to figure out our predicted y's, but we don't have equations because I just had you guys draw your best line of best fit on here, right? Just had you draw one, didn't I? So where are we going to find our predicted y's? We can't plug them into equations, so we have to look at the
best fit.
The best fit line. Perfect. So for this one right here, if I want to find the predicted y when x is 1, I look at my graph and find the y value when x is 1. So here, the y value is 1. Okay. When x is 2, the y value is 2. When x is 5, or 3, sorry, the y value is? No, it's not. 3. Okay. The actual value is 5, wasn't it? Right? The predicted value was 3. That's where the line is at. Does that make sense? Okay. Now to find residuals, do we do actual minus predicted or predicted minus actual? Good. Actual minus predicted. Alphabetical order. A minus P. Alphabetical order, right? So I can remember it. Actual minus predicted. So 1 minus 1 is? 0. 2 minus 2 is? 0. 5 minus 3 is? 2. So we found some residuals. Does that make sense?
Yes.
Yeah.
Okay. Next one. Which on here is my actual values? The blue or the green? Blue. Blue is my actual values. Which one's my predicted values? Green. Right? So to find my predicted y when x is 2, we look at the line or the point? The line. So when x is 2, what's y? 3. When x is 6, 1, 2, 3, 4, 5, 6, what's y? 7. No.
Well,
1, 2, 3, 4, 5, 6.
we have a different.
Yeah, we have different.
Right. Yours might be different than mine. That's fine. If yours is different, then you guys can do it with yours. Okay? It doesn't have to be exactly the same as mine. Okay? I'm just kind of showing you the method here. Okay? So when x is 6, y was 1, 2, 3, 4, 5, 6 points. Maybe 3. Well, 6 would be right here. Okay? 6 is right there. Okay. We're above 6. Right there. So we'll call it 6.3. Okay? Who said they don't know what's going on? Okay, Maddie's right here. So when x is 10, right? When x is 10, we figure out where our green line is at. Okay? That's at 10. So that's my predicted value. Okay? And then the actual values are the ones that we plotted in blue. Okay, do you see the difference? Okay. And to find the residual, we do actual minus predicted. Now guys, I know yours is different, and that's why I'm going through these right now, because in a second I'm going to have you finish yours up. Okay, does that make sense? So right here in a moment, I'll have you finish yours up, okay? So this last one, so those of you that volunteer, you get one that you know is 100% right. All right, so 3 minus 3 is what? 0. 7 minus 6.3 is? 0.7. Hey, that residual is positive. 10 minus 9 is? Or sorry, 9 minus 10 is? -1. Hey, that one's negative. Positive. Above the line. Negative. Below the line. Interesting. Okay. All right, last one. So down here. When x is 1, y is... I think it's just below 5. What do you guys think? Think it's on 5 or just below? Just below? Okay, we'll call it 4.9.
Yeah.
4.9. Okay. Next one. X is 3. 1, 2, 3. Y is 1, 2. I think 2.5. Yeah. And when x is 5, y is, looks like 0. So 5 minus 4.9, what's that? 0.1. 4 minus 2.5, what's that? What is it? 1.5. 0 minus 0, what's that?
0.
Yeah.
Like, how do you know where to draw the line if it's only like 3 points? So it could either be like.
That is a great question. So the question was, how do we know where to draw the line? And this is the point I'm making here, and we'll probably have to make it tomorrow because I'm going to get to it today. All right? But the point is, when you draw your lines, guys, your line of best fit won't be right. We need to find a...
R.
Nope.
No.
We need to find an...
Equation.
Equation. Okay? We need an equation. Where do we find the equation? What do you think we use?
The data.
The data and our...
Y and variables.
What'd you say? Tables? Almost.
Regression.
Our data and a regression line that our calculator will find. Okay, so before you go, what I need you to do is I need you to figure out all of your residuals if they're different than mine. Okay? And one thing I want you to do is down here, I want you to find the sum of your residuals. So here, 0 plus 0 plus 2 is 2. 0 plus 0.1 plus -1 is? Negative 0.3. 0.1 plus 1.5 plus 0 is? 1.6. So I want you to find the sum of the residuals as well. All right? Any questions?